This is Solutions Test Review, questions 4, 5, 9, and 10 that all deal with either molarity or stoich. Sorry, molarity and stoich. So question 4 asks us what mass of barium sulfate can be produced when 200 milliliters of 0.1 molar solution of barium chloride is mixed with 150 milliliters of 0.15 molar solution. First thing that we need to do is convert our volumes and molarities to moles at 0.1 molar solution, and I'm looking for moles, and that's X over 0.200. Remember that this is in milliliters, so we have to convert to liters. And then we're going to have a 0.15 molar solution, X over 0.150. Okay, so this one we get 0.0225 moles, and on this one we get 0.02 moles. This top one is for barium chloride, BaCl2. This is where we're going to start our stoich. They've given us a balanced chemical equation, so I'm just going to go from barium chloride. That's what I need to get rid of, is the moles of barium chloride. And I need to go to barium sulfate, and that's 3 moles BaSO4. And then I need to determine the mass of barium sulfate. So barium has a mass of 137.328 plus sulfur, which is 32.066, and 4 oxygens, giving us 233.39 grams per mole. Whoops, not BaCl2, BaSO4. Okay, so when we multiply 0.02 times 3 times 233.39 and then divide by 3, you get 4.6678, and then we're going to finish this stoich before we determine if that is the smaller amount. So this one was for iron 3 sulfate. Okay, in this one we have 1 mole of iron 3 sulfate for every 3 moles of barium sulfate. The molar mass is not any different, so 233.39 grams barium sulfate for every 1 mole of barium sulfate. Again, we're going to multiply the tops. All the bottoms are 1, so we don't need to really divide by the bottom. So This one comes out to 15.7538. So that means that this is the smaller amount, and barium chloride is our limiting reactant. Now we're going to look at sig figs. 3, 4, oh, we don't count that one. 4, 3, 4. We only count the measured numbers, so it's going to be 3, so 4.67 grams of barium sulfate. Again, we have another stoich. This one doesn't give us the balanced chemical equation, so we need to write that real quick. KNO3 plus AlOH, and that's our solid. This one's going to be aqueous, so I'm going to need 3 of these, 3 of these, 1 of these, 1 of these. Okay, so first thing we're going to do is take our volume and mass of aluminum nitrate, so 0.2 molar equals X over 0.05 liters. Which gives us 0.015 moles of AlNO3. Okay, for every 1 mole AlNO3, we get 1 mole AlOH3. And then we're going to find the molar mass of aluminum hydroxide. I run out of board. Okay. So, multiply the tops, multiply the bottoms, divide the top by the bottom. All the bottoms are 1s, so we get 1.17005. Okay, so now we're going to take this reactant, and we got 0.1 molar equals X over 0.250 liters, which gives us 0.025 moles of KOH. Our mole to mole ratio is that every 3 of these moles creates only 1 mole of this. Our molar masses aren't going to change. That's a 0, not a 6. Okay. This time all of our bottoms are not 1, so I'm going to multiply the tops, and then I'm going to divide by the bottom, which is going to be 3. That gives us 0.650025. This is obviously the smaller one. 3 sig figs, 4, 3, 3. So my final answer has to be in 3 sig figs. That wasn't very good. There we go. Number 9. This one only has one reactant that we have to worry about. Oh no, we're going from one reactant to the other reactant. And in this case, they want mass. So I'm going to first take my molarity with my volume to find moles. And this is AgNO3. And is this a balanced chemical equation? It is. So for every 1 mole of silver nitrate, I need 1 mole of sodium chloride to completely react it. Now I just have to find the mass of sodium chloride. Which I get 58.443 grams NaCl for every 1 mole that we produce. Multiply this out, and that means that we need 2.33772 grams, and we have 3 sig figs, so I'm going to round this at 2.34 grams. Last question. We have a molarity and volume of one reactant, HCl, and we are looking for the mass of another reactant. So we'll just start this one just like any other. 2 molar equals X over 0.100 liters. That gives us 0.0, nope, sorry, too many zeros. 2 moles HCl, and then I'm just going to follow my units. And is this a balanced chemical equation? Yes. So for every 2 moles of HCl, I need 1 mole of calcium carbonate. Now I just have to find the mass of calcium carbonate. So calcium 40.078 plus 12.011 plus 15.999 times 3 gives us 100.086 grams for every mole. Multiply our tops. Multiply our bottoms, which comes to 2, divide the top by the bottom, and we get 10.0086. 3 sig figs, so 10.0 grams. That is